Hello, class. Welcome to our next lesson in 8th grade Eureka Math. We're in Module 3 still. Today is Lesson 5, the consequences of FTS. And remember, we learned FTS means the fundamental theorem of similarity. So we're going to use what we learned in Lesson 4, the last lesson, to help us with our dilations. The fundamental theorem of similarity taught us two things yesterday. It taught us that the dilation of a line makes a parallel line, and it taught us that all lengths of a dilation are changed by the same scale factor. The scale factor changes all the lengths. So we're going to use those two little pieces of knowledge to help us with some dilations, this time on a coordinate grid, on how to graph dilations. So the FTS, the fundamental theorem of similarity, helps us to graph our dilations better. So that's the title of the lesson. We're on pages 49 to 58 of your workbook, so make sure you have those pages out and ready to work on. Also make sure you have your notes ready to go and that you are copying the notes you see on the screen. So let's talk about the road so far with what we've learned so far in Module 3. We've learned, number one, dilations change size but not shape. A dilated square is still a square. A dilated line is still a line. A dilated triangle is still a triangle. A dilated segment is still a segment. Dilation does not change the shape, but it can change the size. It can make things larger or smaller. Number two, dilations use a scale factor and a center. All transformations have to follow rules. In Module 2, we learned about how a translation has to follow a vector, a reflection has to follow a line of reflection, and a rotation follows degrees and a center. A dilation is still a transformation, just not a rigid transformation. But a dilation, the rules for a dilation are scale factor and center. A scale factor tells us how big the change is going to be. The center tells us what direction. Number three, we learned that the angle degrees do not change with dilations. The lengths change, the sides of a figure change, but the angles do not change. If you dilate a 30-degree angle, it will still be a 30-degree angle. If you dilate a 45-degree angle, it will still be a 45-degree angle. So even though the length of the figure changes, the degrees do not change. And that's because the degrees do not change because all the lengths change the same. So the ratio of the lengths stay the same, so the degrees stay the same. Number 4 and 5 are the ones we learned yesterday with the fundamental theorem of similarity. Dilating a line makes a parallel line, number 4. When you dilate a line, you just get a parallel line. And number 5, the scale factor changes all the lengths in a dilation. Every length is changed in a dilation. And that fact, number 5, is really going to help us today make dilating a little bit easier on a graph. So that number 5 is going to be very important today. The scale factor changes all the lengths. It changes the width, it changes the length, it changes the perimeter. Everything in a dilation every length in a dilation is changed by the scale factor. We also learned the equation for a dilation. The dilation equation, if you want to, when you solve it mathematically, you take the original image, the original figure, whatever it is, if it's a line, a segment, a triangle, a square, whatever, you multiply it by the scale factor, which is r, and that makes the dilation. So the original times the scale factor makes the dilation. You can also write in symbols where we have like the figure p times r equals p prime. So p prime is made by doing the original times the scale factor. And that works for all measurements. This is the equation you have to remember. If I give you P and I give you R, you can find the prime. You can find the dilation. If I give you the original and the dilation, you can use algebra to find the scale factor. So you can find, if I give you two of these pieces, you can find the original. You can find the missing piece. So this equation we're going to use today, it's important for you to know, so write it down and try to memorize it. So today, what we're going to do is we are going to use the dilation equation and Rule 5 that is still on your screen up here to dilate figures on graphs. We're going to use the dilation equation and Rule 5 to dilate using graphs. So those are the notes today. Make sure you have all the notes. Maybe pause the video for a minute. Check to maybe go back and see if you need to copy down if you missed any of the details. But after your notes are complete, you can restart the video and we will get going on page 49 and start learning more about dilations and how to do them and how to find information using them. Okay, so hopefully you checked your notes and they are complete and you're ready to work. So let's leave the note page and let's go to page 49, which has exercise 1 on it. Exercise 1 is a line that's been dilated from center O. So it says points P and Q have been dilated from center O by scale factor R. So scale factor R. PQ is parallel to P prime Q prime, so we have two parallel lines. PQ is 5, and they label it for us on the diagram. And P prime Q prime is 10, which they also labeled for us on the diagram. So they set it up, they dilated points P and Q, they connected PQ, they connected P prime Q prime, just like we did in lesson 4 yesterday. They did the same thing. And they labeled the lengths for us. So now we need to determine, part A, determine the scale factor R. What scale factor did they use to dilate this? Well, so R is missing. But we can use the equation we put in our notes. Remember the dilation equation? The original times the scale factor equals the dilation. The original times the scale factor equals the dilation. So in this case, the original is PQ. The dilation is P prime Q prime, and R is missing. So we know, using the equation, the original PQ times the scale factor R equals the dilation, P prime Q prime. The original times the scale factor equals the dilation. Original times scale factor equals dilation. So now we just need to put in what we know and solve it. So the original PQ, they told us, was 5 centimeters. R is what we need to determine. So R is still R. The dilation, P prime Q prime, was 10. Now to find R, we do algebra, or actually you can probably do this with mental math. 5 times something makes 10. 5 times something makes 10. Well, you know, because you know mental math, that R has to be 2. Because 5 times 2 makes 10. But let's pretend you did not know that and you need to do algebra. To find it using algebra, we want R by itself, so we need to do 5 divided by 5. Because 5 divided by 5 makes 1, and 1 times R is R. So that's how we get R by itself. We divide by 5. But if I change this side, I have to change the other side, so I have to do 10 divided by 5. And 10 divided by 5 is 2. So that's how we find it with algebra. You probably did it with mental math, but it's important to know how to do it with algebra because it will not always be that easy. So now the scale factor is 2. Good, we know that. In fact, right now for part B, it says, measure these segments to verify that OP prime equals R times OP and OQ prime equals R times OQ. So we need to prove that the scale factor works for OP and OP prime, and that the scale factor works for OQ and OQ prime. So does the scale factor work? Well, I have my ruler. Let's start with OP. Well, they say it's 3 centimeters, but it's not really. If you look at my ruler, OP looks like it's about 2.3 centimeters. 2.3 centimeters. But if the scale factor is true, if the scale factor is 2, then this should be 2.3 times 2, so this should be 4.6. And if you look, it is 4.6. You can see where the dot hits at 4.6. So, yes, OP, so this does work. We found out that OP prime equals R times OP. We measured and we said OP was 2.3, and we measured OP prime and we got 4.6. R we know was 2. So we do 4.6 equals 2.3 times 2 is also 4.6. Check, it is true. So the scale factor works for this side. Let's measure the Q's to see if it works on this side. Now it tells us it's 4 centimeters, but something tells me that they probably are a little bit off. Yeah, if you look at that, it's not 4. It's actually 3 on my ruler. You can see where the Q stops, it's 3. So I'm going to say, nope, they lied, it's 3 centimeters. So OQ prime should be 6. And if you look at that, it is 6. So they lied again, and it's 6 centimeters. So let's show that that also follows the scale factor, because we know that OQ prime should equal R times OQ. And we measured, and we found out that OQ prime was 6 centimeters, OQ was 3 centimeters, and we said R is supposed to be 2. Which, if you do the math, you find out that 6 equals 2 times 3 is also 6. So that is also true. So you see that the scale factor follows all pieces of this. The scale factor is true for all the pieces. The scale factor is true right here, where 5 times 2 makes 10. The scale factor is true right here, 3 times 2 makes 6. And this, or what, it wasn't supposed to be this. They lied to us, I remember. This was 2.3 and this was 4.6. So 5 times 2 makes 10, 2.3 times 2 makes 4.6, 3 times 2 makes 6. So this is all true. The scale factor is true everywhere. This was just a reminder about fact 5. The scale factor is true for all lengths in a dilation. All lengths. This part right here with P and Q was just meant to show you how it works for all the lengths in a dilation. Because we're going to use that fact, that scale factor works for all lengths, to help us with the rest of the lesson. So let's turn the page. Go to page 50, which has exercise 2 on it. In fact, it's a big graph right here. Let's read the instructions before we pull it down and look at the graph. In the diagram below, you are given center O and ray OA. Point A is dilated by scale factor R equals 4. So R equals 4. Use what you know about FTS to find A prime. Okay. So we know center, we know OA, and we know the scale factor. we need the dilation. We need to find A prime. Well, here's the graph now. You can see center O is at the origin right here. We have to find it, identify it. Here's A. That's the original. And the scale factor, I'm going to write on the side so we can still see it because you cannot see the top of my page. R is going to be equal to 4. Now, there's a couple ways to do this. What you might say is, well, okay, well, Mr. Baylor, I need to measure right here. I measure right here, and that is going to be 4.3. So you might say, okay, if A is 4.3 away from the center, then I need to do 4.3 times the scale factor. So 4.3 times the scale factor. Let me get my calculator, Mr. Baylor. It's going to be up here somewhere. Well, you can do that if you want. But there is an easier way when it's on a graph. Because remember Rule 5. The dilation changes all the lengths. So one way is to measure this blue line and multiply that by 4. You can do that if you want. But you have to do 4.3 times 4, and you might not get it exactly because it's kind of tough to measure. There is a different way. Because remember, number 5, the scale factor changes everything. So the scale factor changes the blue line. But what happens if I turn this into a triangle? Excuse me. Because if the scale factor changes everything, it changes the blue line, but it also changes the green lines because it changes everything. It changes everything. So instead of getting your ruler and measuring the blue line and hoping you measure right, what if we just look at one of the green lines? We don't even need to do both the green lines because look at this. Right here, this A hits 3 on the x-axis. So if we find 3, we go up, we get A. Well, what if I just do, instead of measuring the blue line, what if I just do the 3 times the scale factor? 3 times the scale factor, 3 times 4 is 12, which means it grows over all the way across to 12, which means if A was at 3, then A prime is going to be up to 12. So A prime is going to, I follow 12 all the way up until I hit the ray. I hit this, remember, this line tells me the direction. So I go where 12 hits the right direction. So that is A prime right there. That was much easier than doing 4.3 times 4. I just did 3 times 4. And it works if you also measure up too. Let's say if I wanted to measure the red. I know that it goes up, A goes up 3 on the y-axis. 3 times 4 is 12. So instead of going up 3, I go up 12. And you can see that because of the FTS, because you know that the scale factor changes everything, you do not have to measure. If it's on a graph, you do not have to measure the blue line. You can measure the green line or you can measure the red line. You do not need to measure the blue line. Now, if we can check it with the blue line and say, okay, this is what, 4.3? So if you do 4.3 times 4, that should be 17.2, which is about where we hit right here. It's close. Might not be this graph might not be perfect squares. That might be why it's messing us up. Yeah, it doesn't look like it's perfect squares. But that's why we use FTS, we use Rule 5, and we say, I don't need to measure the blue line because I don't know if whoever made this graph made it perfect. Measuring the blue line only works if everything's perfect. Instead of measuring the blue line, we can go the green and do 3 times 4 makes 12, or we can do the red and say 3 times 4 makes 12. And that is how you can find A prime, kind of using mental math. Let's look at another example. Go to page 51, exercise 3. This is our last example we're going to look at. And this one is actually going to be with a fraction scale factor. Because if you look, it says in the diagram below, you are giving center O. So the center, let's find it, is at the origin. You're giving ray OA. Ray OA right here. I'm going to make it blue. And the scale factor is R equals 5/12. And now what you need to do is you need to find point A prime. You need to find the dilation. Well, you're going to use the equation. Remember, the equation is A times R equals A prime. A times R equals A prime. So one way to do this is not the way I want you to, but if you want, you can measure the blue, and you can say that looks like 12.7 centimeters. 12.7 centimeters. So you can say 12.7 times R, which remember was 5/12. 12.7 times 5/12 equals A prime. And then you can measure it, and after you find your answer, you can put it somewhere where it goes. Now, that's what you could do. I wouldn't do that because that math does not look very fun to me. So I would not measure the blue line. If we use the blue line, this is what you have to do. But I will not do that. Instead, I would say, well, you should either measure, remember, the green line. There's where you get to be A. Or you measure the red. Now, here's where you need to kind of make a little decision about what one's easier. Because if you measure the green line, remember, we're using Rule 5. You can choose to either use the green line and say A times R equals A prime, or you can choose the red line and say A times R equals A prime. We do not want to use the blue line. The blue line math was super complicated. So let's decide what's easy. The blue line math, not fun. What's the red line math look like? Well, A on the red line, A, if we look at A, we go all the way to the red line, A is 8 on the red line. So A is 8. R, remember, in the question says 5/12. So we do 8 times 5/12 to find A prime. That's the red line math. The green line math, A, if we go down to the green line, A is 12. So we do 12 times r 5/12 equals a prime. Now, if you show me these three choices, blue line, red line, or green line, I'm not going to do blue line because that math was messed up. Now, red line and green line, let's do both of them. I'm going to do both of them with you. Some of you see that one of them is much easier than the other, but I'm going to work on both. So 8/12, 8 times 5/12 equals a prime. So let's do 8. Let's turn 8 into a fraction so that we multiply in fractions together. We have 8 times 5 divided by 1 times 12 equals a prime. Now, to do this, what you should do is you should do break it up. So 8 is actually 4 times 2. So we get 4 times 2 times 5. 12 is 4 times 3. So we do 4 times 3. So we get 4 times 2 times 5 divided by 1 times 4 times 3. We have a 4 in the numerator and a 4 in the denominator, so those cancel. So now we just multiply what's left. So we get 2 times 5 is 10, and 1 times 3 is 3. So a prime is going to be 10/3. Or you can say it is 3 1/3 equals a prime. That's where the red line is. So what you would do, if you say a prime is 3 1/3 on the red line, then you go to the red line, you go to 3 1/3, and then you go back over this way until you hit the ray. But let's do the math again for the green line. Let's still turn 12 into a fraction. And let's multiply straight across. 12 times 5 divided by 1 times 12 equals a prime. And you're going to see right here that there's a 12 in the numerator and a 12 in the denominator. So those can cancel. So we just left with 5/1 equals a prime. So 5 equals a prime. So this can tell us where a prime goes, because I know a prime hits 5 on the green line. So I find 5 on the green line, and I go up to where it hits the line, and that is where a prime is. And if you look, a prime is 5 on the green line, like we said it was going to be. And a prime is 3 1/3 on the red line, just like we said it was going to be. So we found a prime by using the scale factor. We found a prime. But which one was the easiest way to find a prime? The blue line was not the easy way. The red line was not super easy. But the green line, the math for the green line was the easiest way. So that's the way I would pick. You do not need to use the blue line. You do not need to use the red line. You can just use the green line. And some people might have even realized that might have even realized that the green line was going to be easier at the beginning, because when you saw that r equals 5/12 and you saw that a hit 12 down here, you should have said, wait a second, 12 and 12. 12 and 12. So if a hits 12, this is going to be the easier math right here. In fact, if the scale factor is 5/12, we started at 12 on the green line. Where did we end up? We ended up at 5. So this math got even easier when you saw the scale factor was 5/12. You saw a go from 12 to 5 on the green line. So that's an easy way to do it. Now, all three ways will work. You can use the blue line, measure, multiply, and find the prime. You can use the red line. 8 times the scale factor will give you 3 1/3 right here. Or you can use the green line. You do 12 times 5 twelfths, and it will tell you where A prime is. You can use whatever strategy you want. There's 3 choices here. I am just telling you, use the green line. Use the one that's easier. Sometimes this way will be easier. Sometimes this way will be easier. But remember, any of these work. All 3 will work because the fundamental theorem of similarity, FTS, tells us that the scale factor changes all the lengths. The scale factor shrinks it on the blue. The scale factor shrinks the green. The scale factor shrinks the red. So you can use whichever one you want. You can just decide what will be easier for you. So that was exercise 3. Take a minute, check your work, make sure you understand it. Go back and watch the video again if you need to. And then when you unpause the video, we will talk about your problem set and your exit ticket for today. So take a minute, look at all that. Make sure you understand how I did it and why I did it. Okay, everybody, hopefully you went back and looked at the 3 exercises we did, and you found out that using the length that works best for the math, any 3 lengths, any of these will help you find the dilation. Let's talk about the problem set and the exit ticket. On page 52, you'll see that they have the lesson summary for you. You don't need to worry about this. This is just talking about how you can find the dilation using any length in it you want. Any length works to help you find the dilation. Page 53 is the exit ticket. That's going to be the last thing we talk about. It's going to be what you turn in today, so I'm going to put that into the back of my packet. The homework helper starts on page 55, and if my explanation was not good enough, or if you want a different explanation, you can always look at the homework helper. It gives you a question, gives you the diagram, it gives you the work and the answer, and it even gives you the little talk bubbles where it tells you what they were doing in their mind. So the homework helper is a good tool if you need help. And the homework helper goes on 55 and page 56. Now this, page 57, is the start of your problem set, where number 1 says, dilate point A located at 3, 4 from center O by scale factor 5/3. So the scale factor is 5/3, and it wants you to dilate point A, which means you can either measure and make, so you know if you follow this line, the answer has to be somewhere on that ray, on that line. Now you can either measure this and multiply some weird decimal times 5/3, or remember, it works for any length. So instead of you can use the blue line, but I think the math on that is going to be complicated. Or you can use the green line, or you can use the red line. But you can do whichever strategy you want to put the point A prime wherever it goes. So just show me where A prime is. For this part here, what is the precise location of A prime? What it wants is it wants coordinates. It wants x, y. So it wants A prime of x, y. So just tell me what the coordinates are for A prime. So to do that, to find the exact coordinates, you will probably have to do the math for the green line and for the red line. So do the math for green line and red line and tell me what the coordinates are. For page 58, also for this one, I think there's a homework helper that will help you with this. Yes, Homework helper number 1 on page 55 will help you with this. So if you need help for number 1 on your problem set, homework helper, page 55, number 1. That will tell you, that will show you how to do it. They tell it's the exact same kind of problem, just a different point. Page 58. This is going to be like homework helper, page 56, number 2. It says dilate point A, located at 9,7 from center O by this scale factor, then dilate point B from center O using the same scale factor. So where are A prime and B prime? So they want you to find where are A prime and B prime using that scale factor. Again, I would recommend not using the diagonal. Do not use the diagonal. You turn it into a triangle and use the legs. Turn this into a triangle and use the legs. That's what I would try to do. And then number 3 says, explain how you use the fundamental theorem of similarity in problems 1 and 2. That's just asking how did you use legs and not the diagonal? Why is that okay? And as a little hint for that part of the problem set, number 5 on your notes. The scale factor changes all the lengths. So if the scale factor changes all the lengths, you can go down and across. You can do this. If the scale factor changes everything, you can use these. You do not have to use the diagonal. You do not have to use the hypotenuse. But that's the problem set. You can practice on the problem set, and my answers will be posted on the Google Classroom, so you can check your answers with mine. And then when you check your answers and you know what you're doing, it's time to work on the exit ticket, and this is the exit ticket right here, where you are given point A and scale factor 6/4, and it wants you to find the location of A prime after the scale factor. And again, I would not use the diagonal. I would turn it into a triangle, and I would use the legs. Instead of using the scale factor, instead of using the diagonal, instead of using the hypotenuse, I would use the legs. So that's my advice. That's the explanation for how to do it. If you need my help, ask me. We can do a private meeting, and I will show you how to do these. We can talk about it some more. We can work on it some more. I want you to do well, so please ask me if you'd like my help to do the best you can. If you understand it, awesome. If you don't, ask for help, please. And I will see you for the next lesson, lesson 6 of Module 3.